Okay, so good day everyone. So our lesson is about the lesson 4.1 anti-differentiation. You already familiar with inverse operations. Addition and subtraction are inverse operations. Multiplication and division are inverse operations also. As raising to powers and extracting roots. In this section, we develop the inverse operation of differentiation, and that is called anti-differentiation. By definition 4.1.1, a function big F is called an antiderivative of a function small f on an interval I if the first derivative of big F of x is equals to a function f small f of x for every value of x in I. Okay, for illustration 1, if big F is defined by a given polynomial function, so big F of x is equals to 4x cubed plus x squared plus 5, then its derivative, so yung derivative ng ating big F, so big F prime of x is equals to 12x squared plus 2x by definition of derivative. Thus, if small f is a function defined by f of x equals to 12x squared plus 2x, itong ating derivative ng big F, yun naman yung consider natin as small f. We state that the small f of the derivative of big F and that big F is an antiderivative of small f. Okay, another example. If a big G is the function defined by big G of x equals to 4x cubed plus x squared minus 11, then big G is also an antiderivative of small f because if we're going to find the derivative of big G prime of x is equals to 12x squared plus 2x. Mapansin mo yung derivative ng big G at ng big F ay same lang as a function small f. Actually, any function whose function value is given by 4x cubed plus x squared plus c, where c is a constant, is antiderivative of small f. Diba? Kahit magkaiba yung kanilang last term, yung sa big F ay positive 5 at yung sa big G ay negative 11, and it is referred as a constant c, then parehas lang sila magiging antiderivative of small f. Okay, next, the arbitrary constant c. In general, if a function big F is an antiderivative of a function small f on an interval I, and if big G is defined by G of x is equals to f of x plus c, where c is an arbitrary constant, then big G prime of x is equals to big F prime of x, and it is also the same with the small f of x. And G is also an antiderivative of f on the interval I. Okay, let's consider this theorem 4.1.2. If big F is a particular antiderivative of a small f on an interval I, then every antiderivative of small f on I is given by big F of x plus arbitrary constant c, and all antiderivatives of small f on I can be obtained from f of x plus c by assigning particular values to c. So yung tinatawag nating anti-differentiation is the process of finding the set of all antiderivatives of a given function. Okay, anti-differentiation. The symbol, ito tatawagin natin ito, integral sign, denotes the operation of anti-differentiation, and we write the integration of f of x dx is equals to big F of x plus c, where the f prime of x is equals to f of x, and the derivative of big F of x is also the same with the small f of x dx. So yung nag-introduce ng tinatawag nating anti-differentiation ay si Gottfried Wilhelm Leibniz. Leibniz introduced the convention of writing the differential of a function after the anti-differentiation symbol. The advantage of using the differential in the manner will apparent to you when we compute antiderivatives by changing the variable. So we can write into the symbol of the integration of the derivative of big F of x is equals to the F of x plus c. Okay, we have a special annotation under the anti-differentiation. If big F is a particular antiderivative of small f, then we have the integration of the small f of x dx is equals to big F of x plus c. Tinatawag din ito na indefinite integral. So yung ating symbol, yun yung ating integral sign, itong part na to. So yun yung ating integral sign. Then yung f of x ay tinatawag nating integrand. Ito yung ating integrand. Then yung c, big C is the arbitrary constant.